Let me take you on a journey that could change the way you see the world, literally. Have you ever noticed patterns in nature that seem to repeat, no matter how closely or far away you look? Whether it's the veins in a leaf, a snowflake, or even the branching of a lightning bolt, these recurring patterns are part of something extraordinary in science. Today, we're diving into the mind-bending world of fractals, patterns that repeat infinitely at every scale. And let me tell you, this will blow your mind. So, what are fractals? The term fractal was popularized by mathematician Benoit B. Mandelbrot, who described them as a rough or fragmented geometric shape that can be split into parts, each of which is a reduced-scale copy of the whole. That might sound complicated, but stick with me. It's about to get fascinating. Imagine you're walking through a forest. You see a tree with its major limbs branching out. Now focus on one branch. It also has smaller branches growing out in the same way. Zoom in even further to a twig, and you'll see the same structure. That's a fractal, self-similarity across different scales. And trees are only the beginning of where fractals show up in real life. Fractals aren't just found in trees. Let's take a look at clouds. Have you ever tried to draw a cloud and ended up with just a blob? That's because clouds don't form simple geometric shapes. They're fractal in nature. Their shapes have roughness and irregularities that repeat infinitely, no matter the level of zoom. This fractal nature gives clouds that complex, wispy, and endless look we're all familiar with. Now let's zoom out to Earth's geography. Coastlines themselves are fractals. Picture this. You look at a map of a country's coastline. You see jagged edges, bays, and promontories. Zoom into a smaller section of the coastline, and guess what? It's just as rugged and intricate. Zoom in even further to a tiny bay, and the patterns still persist. This means you can't define the length of a coastline because the smaller scales infinitely add to it. Sound crazy? That's the marvel of fractals. But fractals aren't just a natural phenomenon. They've opened up entirely new dimensions in science, art, and technology. You probably use fractals every day without even knowing it. For starters, your phone or computer screen often relies on fractal algorithms to compress images. When you look at pictures online, vast amounts of data are reduced into manageable sizes using fractal math, yet they still retain their visual quality. And don't even get me started on fractals in medicine. Did you know that fractal patterns can be found in the structure of your lungs? Breathing becomes efficient because of fractal branching, which maximizes how much air reaches each part of the lung. The same fractal geometry shows up in your blood vessels, ensuring oxygen is delivered throughout your body as efficiently as possible. Simply put, you're alive because of fractals. Fractals even exist in internet networks. Yep, that's right. Data outputs, connectivity patterns, and even the complex way servers operate can often be understood through fractal principles. Every time you send a message or stream a video, it's like being a part of a fractal system at work. Amazing, isn't it? And we can't ignore the sheer beauty of fractals. From famous fractal artworks to computer-generated Mandelbrot and Julia sets, fractals have inspired countless forms of creativity. Fractal art isn't just stunning, it reveals the infinite possibilities of patterns that we can barely begin to comprehend. Talk about art imitating life. Now, while fractals might seem like a magical concept, they're deeply tied to fundamental mathematics and biology. They help us understand the principles of chaos theory, which describes systems that are sensitive to initial conditions, like the weather. Weather systems, after all, are riddled with fractal patterns. Just think about hurricanes or the ripple effect of a pebble dropped into water. But wait, there's more. Have you heard of fractals in space? Astronomers have studied galaxy clusters and found that the distribution of stars and galaxies forms fractal-like structures. This discovery hints that fractals may be a universal constant in how matter organizes itself, whether on Earth or out in the cosmos. Let's not forget music. Believe it or not, some musicians have mimicked fractal patterns to create hauntingly beautiful compositions. The repeating themes in a Beethoven symphony, or the layered textures in electronic music, those could be seen as fractal-like elements, creating harmony through repetitions and variations. But why are fractals so ubiquitous? One reason could be their efficiency. Nature often opts for highly efficient designs, and fractals allow for maximum functionality with minimal input. Think about lightning, for example. The branching fractal pattern minimizes resistance, allowing electrical energy to travel efficiently down to the ground. Or coral reefs, whose fractal surfaces maximize oxygen diffusion to sustain a bustling ecosystem beneath the water. Now, let's tackle how fractals are calculated. Mathematically, they rely heavily on iterative processes. Take the Mandelbrot set, the most famous fractal in mathematics. It's calculated using simple equations applied repeatedly. Each iteration brings out more detail, revealing infinite complexity. That's why fractals feel both accessible and mysterious. Simple rules create patterns of unimaginable detail and beauty. So, how can you see fractals firsthand? Start by observing nature. Look at the veins of a leaf, the branches of a tree, or even broccoli. Yes, broccoli, specifically Romanesco broccoli, is one of the most stunning examples of natural fractals, with its logarithmic spirals repeating at every scale. And did you know fractals have therapeutic qualities? Seriously. Studies suggest that looking at fractals or fractal-inspired designs can lower stress levels and enhance focus. That's why fractals are often incorporated into architecture, art, and design. It's almost like they're hardwired into our brain's sense of beauty and calm. Alright, so why does this matter? Learning about fractals sheds light on the hidden geometry of the world around us. It's a constant reminder that order and chaos coexist in fascinating ways. They show us that infinite complexity can spring from the simplest of rules, and that the boundaries between art and science are gloriously blurred. So the next time you're outside, take a closer look at the world around you. From the spirals of a sunflower to the ripples of waves meeting the shore, fractals are everywhere, whispering secrets about the nature of existence. Remember, the deeper you look, the more there is to find. And isn't that just the most exciting thing?